Thank you, Levi, and welcome everyone to this month's Connect with Remedy webinar. We have an exciting topic this month, and wanted to go through some housekeeping. If you have questions during this presentation, you can use the Q&A pod to ask your question, and our panelists from engineering and support will answer those questions. And at the end, we will ask questions of our presenter. And if you have any questions or audio problems, you can hit *0 to speak to the operator to help work on those. This month's presentation will be on troubleshooting performance issues in Remedy Java applications. We have Chetan Hiwarale is our presenter. He is a product developer in engineering. At this point, I'll turn it over to Chetan. Thank you.
Thanks, Rick. Hello, everyone. This is Chetan Hiwarale, and I will be driving this presentation today. So, as we all know, this webinar is based upon troubleshooting performance issues in Remedy Java application. So, let's start. So, here is the agenda for this today's session. So, I will be talking about the common performance issues which one may observe while working with any Java application. Then we will see some tools which can be used for monitoring and analysis of the performance issues. Then we more specifically talk about Java Visual VM tool which can be used for performance monitoring and for profiling of the Java applications. Then we will see the setup part of it. I mean how we connect our Java Visual VM instance to different Java applications. Then we will see how we can collect logs or dumps using Java Visual VM tool. And at last we will learn how one can do basic analysis of these logs and dumps for troubleshooting any performance issues in Java application. So this is what the agenda for today's session. So moving on to the first topic. So let's see the common performance issues one may observe while working with any Java applications. It is not just related to the Remedy applications, but it can be observed while working with any Java application. So here I have mentioned 4 performance issues. I will talk in detail about each, and I will tell you what data needs to be collected in each scenario for troubleshooting these issues. So the first common performance issue will be like intermittent hang in application. So sometime while working with Java application, we may see a sudden hang in the application, or we may see a multiple times intermittently application is getting hang. So in this case, we would need to collect thread dumps, and that thread dump should be collected when the application is in hang state. Then we would need to collect garbage collection logs and CPU utilization. So from thread dump, we will able to check if there is any deadlock in the application. And from GC logs, we will see if there is a high frequency of garbage collection which is causing the hang in application, or we can also analyze CPU utilization for that particular time frame. Then the second scenario would be like slow increase in load which leads up to the hang. So for this scenario, we will need to capture application snapshot. And what we will do with that snapshot, from the application snapshot, we will identify the time frame for which the load is getting significantly increased, and then for that particular time frame we will analyze what activity was being performed in the application. So this way we can do troubleshooting in this scenario. Then the third scenario will be like slow performance, or we can say high response time. So sometime in Java application we may observe slow performance for a particular use case, while the other use cases works fine. So that could be one performance issue for that particular case. In this scenario, we would need to capture application snapshot, thread dump, and what we will do with this. So from application snapshot, we will able to track down at what time performance is getting slower, and we can analyze the thread dump for that particular timestamp to see if any thread is taking longer time than the usual. And the fourth scenario would be like out of memory. So sometimes our Java application may log out of memory exception. So that could be one performance issue. And to troubleshoot that issue, we only would need a heap dump. So this is what we need to do for based on the scenario. We need to collect the data which I have mentioned in the right side of the table, right column of the table. Now let us see what are the tools available to analyze such a performance issue and to monitor our Java application. So we have a Java Visual VM tool. So that also can be called as a JVisual and that JVisual VM tool comes bundled with the JDK 6 and above. So it's as JDK is open source, Java Visual VM is also an open source tool. Again, it's a lightweight tool, can be used for monitoring of the Java application. And in further slide, we will learn in detail about the Java Visual VM tool. The next one is a Java Mission Control. Again, it's open source and it comes with bundled with the JDK 7 and above. The only difference is all the features which Java Visual VM has are there in the Java Mission Control plus some extra feature. And third one is the Eclipse Memory Analyzer. This is again open source tool and it can be used for analyzing a leak issue in the application. So Eclipse Memory Analyzer tool can be used as a standalone application or we can use it as a plugin for Eclipse IDE. Then next is a thread dump analyzer. This tool can be used for the analysis of thread dump and again this is an open source tool. The next is a GC viewer. That is also open source tool and that can be used for garbage collection logs analysis. And the last I mentioned here is a URKit tool. So this is not open source tool, this is licensed tool, but we can use this trial version which provides us a license for 15 days. So URKit tool is used for huge Java application profiling, and in BMC we do have some licensed versions of URKit which our engineers use for internal purpose. So these are the few tools which can be used for monitoring Java application and for troubleshooting of performance issues. Now let's talk in more detail about JVisual VM, or we can say Java Visual VM tool. Yes, this is a performance monitoring and profiling tool. So this tool provides us a detailed information about Java-based application while they are running on a JVM. So Java Visual VM can be used to generate and analyze heap dump. It can be used to generate thread dumps and analysis of those thread dumps. Also we can use it for track down the memory leak issues, or we can use to perform and monitor garbage collection. Also there are some more features of these tools, like this tool can be used for monitoring of Java application on both local as well as remote machines. And another important feature of this tool is like it is a lightweight tool and that can be used on production as well as development environment. So why I'm saying it can be used easily on production, because it comes bundled with the JDK package, and every Java application which runs on JDK may be available on that production environment. Also it is possible to capture the data with this tool and save it locally, and we can share it later with anyone, whoever is going to analyze that data further. So that is also an advantage. And the another advantage, like the one instance of JVisual VM can be connected to multiple Java applications for their monitoring and vice versa. Like we can connect to a single Java application using multiple instances of JVisual VM. So these are few features which I have mentioned here about JVisual VM tool. So here is the snapshot which shows how JVisual VM tool looks like. So as you can see here, JVisual VM tool has several tabs which shows different data. So there is an overview tab which shows the properties of system overview. Don't worry, I will be showing you this tool practically. That time it will be more clear to you. Then another tab is a monitor tab. In this tab we can see the live data for the CPU utilization. I mean, there are 4 panels which shows this data. One is for CPU utilization. The other panel showing us the statistics about the classes loaded and unloaded for that application for that particular time. Then the memory usage of the application for the particular time frame, and the 4th panel shows us live threads which are running in the application. So this way a Java application can be monitored using this JVisual VM tool. Okay, so we have seen how JVisual VM tool can be used for monitoring. Now let us learn how we connect our JVisual VM instance to different remedy applications. So here I will be talking more specifically about the 4 remedy applications, and those are Midtier, Smart Reporting, AR Server, and Plugin Server. So the reason here I mentioned Smart Reporting and Midtier together because both the applications run on the web server, so the steps for the connection with JVisual VM would be same for Midtier and Smart Reporting. There is no difference between these 2 applications in the steps how we connect to the JVisual VM. So let us learn for each application how to connect with the JVisual VM. Let's first see how a Midtier or Smart Reporting application can be connected locally to JVisual VM instance. So for that, the first thing we need to do is we need to add these 3 JVM arguments to the Java options of the Tomcat process where these applications are running. So these 3 JVM arguments talks about, the first argument talks about the port number which can be used for the connection, and the other 2 are SSL which says secure socket layer, and the third one is the authentication. So the second and third, these properties by default we keep it as a false, but if we need any kind of security feature there, then we can make it as a true. But essentially we need to define a port number which can be further used for the connection. So these are the 3 JVM arguments which we need to set in the system properties, or we can say in the Java options for the Tomcat process. Then the next step would be we need to start our Visual VM instance on the same local machine where our Java application is running. Since I am telling you the steps for local connection, I will be telling you the steps for the remote connection as well. So then as the second step mentioned, start your Visual VM instance, and then in Visual VM application you will see a panel called application, and in that panel there are 2 sub panels like local and remote. Then click on the local label, right click on it and just say add JMX connection, and it will open a window which essentially talks about the connection properties. Then you need to add the host name and the port number which we have defined in the JVM argument. So you can see here a JMX connection is created under the local tab with the JMX symbol. So I will show you these things practically, but let me quickly go over the next few points which show us how we connect remotely for the Midtier and smart reporting. So we have seen how we connect for remote connection. Now let us see for we have seen for a local connection. Now let's see for the remote connection. So there is no much difference for the remote connection. Only difference is along with these three JVM arguments which we talked about earlier, we need to add one more extra JVM argument in the Java options, and that is the host name. So this parameter would be used to connect application remotely. So for remote connection, these are the four parameters we need to add as a Java options, the JVM argument, and then the rest of the steps would be same. Only difference, we need to create a connection under remote label. Just right click on the remote and say add JMS connection, and the rest of the steps would be same. So this is how we connect our Midtier or smart reporting to Visual VM. Now let me show you how we do it practically. So I'm sharing my screen and switching from this presentation. Okay. So this is my virtual machine where my Midtier application is already running. Now I want to connect to my Midtier application using Java Visual VM instance. So to open the Java Visual VM, first we need to go to the directory where our JDK is installed. So in my environment, it is installed at the path AR Java, and I have a JDK 1.8.0 hyphen underscore 45. So in that JDK directory, go to the bin directory, and in the bin directory you will find an exe file, that is jvisualvm.exe. Just double click on it and it will open an instance of jvisualvm for you. Okay, so our jvisualvm instance is up now, and now we need to connect it to our Midtier service which is running on the same machine. So as I had mentioned in the step, I need to connect to I need to create a local connection for it. So I'm just right click on the local label and say add JMX connection. Now in this window, the connection field, we need to add a host name and the port number which we had defined in the JVM options. So for my Midtier application, let me show you where I have defined these parameters. So I'll go to the Tomcat directory, and inside the Tomcat in the bin directory, and here you can see tomcat7w.exe file. Just double click on it. There we have a provision to set our Java options. Go to the Java tab. There you can see Java options defined. So already there are few options defined, and I have make entry of those three JVM arguments which we are talking about. So these are the three parameters I have added here. Port number 1, 2, 3, 4. Then I kept the security parameters like SSL and authentication as false. Now just apply and say OK. But if you are adding this parameter for the first time in your Java options, then you need a server restart. Since I have already added and I had restart of the server, I don't need to restart Midtier service right now. I can connect directly using the port number which I have defined. The port number was 1, 2, 3, 4. Then give some display name. So I'm just putting here Midtier. And just say OK. I don't need to use any credential for this local connection. Just saying OK. And if you can see, it has created a JMX connection for our Midtier application. Now just double click on that connection and it will open a tab which shows multiple tabs with the detail about our Java applications or our Midtier application. So in the overview tab, if you can observe, it, it is showing the JVM parameters which we had added in the Tomcat Java options. So it confirms it is the same application we are connected to. Then if you go to the monitor tab, as I already mentioned, it shows different panels through which we can visualize the live running data for this Midtier application. So you can see CPU usage, memory usage, classes loaded, unloaded, and threads which are running right now. So this is how we connect to the Midtier or smart reporting locally. Now I want to show you how we connect it remotely. So for that, I will switch back. This is my virtual machine, so I will switch back to my local machine, and from that local machine I will try to connect to this remote Midtier service. So this is my local machine. I have my Visual VM instance already running on this. Now to connect remotely, I just need to create a remote host first. So I am just right click on the remote and add remote host. So my remote host name is, I need to add the host name here. And say OK. So it has created a remote host for me. Now I can add my remote connection under this host. Just right click on it and say add JMS connection. So steps are same as we see for local connection. Only difference is we need to use the host name for the remote machine and the port number which we have defined. So it was 1, 2, 3, 4. I'm giving some name. And say OK. So if you can see, it has created a connection, and if you double click on it, it will show us the detail about our remote Midtier application. So this way we can connect both remote or local applications, and that was for Midtier and smart reporting. So now moving back to our presentation. Now let us see for AR server, how we connect AR server with the Visual VM instance both locally as well as remotely. So for AR server, there is a provision, the AR system provides a default port which can be used for JMX connection. So you don't need to add this port in the Java options of JVM argument. So we can use this default port number 61500, and that is, let me show you where it is defined in the AR system. So this is my AR system. I'm just logging in. So in the AR system, go to the AR system administration console, then go to the system, go to the general, and then server information. So here under ports and queues tab, you will see a JMX port is already allocated for this AR system. So we can use this port, and if you want you can change it as well, but then you need to apply the changes, and then you need a server restart in that case. So this is the okay. Now there is other way also where you can add your own port number to the AR system. So for that you need to add again these 4 JVM arguments to arserver.config file, which is located at arsystem arserver.config. So here in this file you need to add these 4 parameters, and just a point to be noted here, if it is a Linux system, then the file name and path would be different. So for Linux, the path will be AR system bin and the file would be arserverd.conf. And rest of the steps would be same for both the local and remote connections. Okay, so point to be noted here, if you are going to use a default port which is provided by a remedy application, that is 61500, so in that case, in the connection field, you need to use this connection string. This is a standard format. So here you need to put your server name and the port is already there, 61500. So use this connection string if you are going to connect through default port 61500, and else if you are using your own port which you have defined in the JVM argument, then the connections string will be simple, like host name and the port number. So this is the window where we add the connection details. In connection field, I have put this standard string when we use default port 61500. And for if you are using this default port, in that case you would need to add the valid security credentials. So you need to add a valid username and a valid password for that. Then check these two options, save security credentials and do not require SSL connection, and say OK. So it will create you a connection to the AR server application. So this is how we connect to the AR server. Let me cover the connection step for the plugin server as well, and after that I will show you practically how we connect to this AR server and plugin server. So for plugin server, again the steps are exactly same. Only difference is these 4 parameters which needs to be added to the file. So these 4 parameters we need to add to the different file which is armonitor.cfg, which is located at AR system conf armonitor.cfg. The parameters are again same. So we need to add these parameters in armonitor.cfg. So let me show you practically. I'm sharing my screen again. So let us first see for AR server. So as I mentioned, we need to add those parameters in arserver.config file for AR server. So this is my arserver.config file which is located at AR system directory. So in this arserver.config, there is one section called JVM options, and here in that section you need to add these 4 parameters which we have mentioned in the slide. So I have added these parameters here. I put the port number 5555 and the rest of the 2 security parameters I kept as a false, and I have defined my host name. So this way I can connect to these AR applications using JVisual. So as I have already added, I don't need a restart because I have done it earlier. But if you are doing it for the first time, if you are adding this option for the first time, then you would need server restart here. So let me show you how you connect to AR server. So steps are again same. Click on local. Right click on add JMX connection, and since we are connecting locally, we just need to put a valid port number here which I have defined as 5555, putting some name, and since I am connecting using my own port, then I don't need to put the credentials. It will connect directly. Just say OK and see it has created one connection. If you double click on it, you will be able to monitor live data coming from the AR server. Now let me show you a remote connection for AR server. For this I am going to my local box, and this is my local instance. Now for remote connection, again I will right click under the remote label. There is one host. Right click on it and say add JMS connection. In the connection string I have put my host name, and the port number is 5555, which I have defined in the JVM argument. Put some display name and say OK. So it has created a remote connection to AR server application. Now I also want to show you the other way to connect to the AR server using the default port provided by Remedy. So for that I have mentioned that we need to use this default and this standard string for the connection. I am using that thing here. Right click on the host name, add JMS connection, and in the connection string I am putting this standard connection string. So here I have provided the host name and the default port as 61500. Now giving some display name, and for this approach I would need to provide a valid user credentials, and those should be a admin user. I'm giving my credentials here for my AR server. And say OK. So you can see it has created a remote connection for our AR system using its default port 61500. So yes, this is how we connect to AR server using Java Visual VM tool. Now let me show you, it's for plugin server. So as I had mentioned, for plugin server we need to add those parameters to a different file, and that is armonitor.cfg file, which is located in AR system conf folder. So open that armonitor.cfg file. There you will see some Java processes are defined. For the plugin server, you would need to first identify the correct process which is responsible to up the plugin server application. So that can be find in file for plugin. So you will see the second entry made here is for plugin server application. So go to the start of this entry. Here you will see the path for the JDK and some few JVM arguments defined. Now as I mentioned, we need to add those 4 JVM arguments here. So I have added those 4 JVM arguments. Here I have defined port number 4444 for plugin server connection, then keeping other 2 security arguments as false, and host name is CLMPUN019807. I have added these parameters to this file. If you are adding it for the first time, then again you need a server restart. Since I have already done this setup, I don't need to restart the server. So let me show you how I can connect to plugin server using this port 4444. Going back to my Visual VM instance, in local label, just right click and say add JMS connection. Now in localhost, in the connection field, I have put the host name localhost and the port for my plugin server application, which is 4444. Giving some name to this connection. and say OK. If you can see, it has created one local connection for plugin server. So similar way you can do it for remote connection as well. Just add the connection under remote label and provide the port which you have defined in the file armonitor.cfg. So moving back to the presentation, this is how we connect to our different remedy applications to Java Visual VM instance for their monitoring. Now let us see how we can connect different types of dumps or logs using Java Visual VM tool. So here I have mentioned about a heap dump collection, thread dump collection, application snapshot collection, and garbage logs collection. So let us learn about each in detail. So as we know, heap dumps can be used for analyzing memory issues, and there are multiple ways for collection of heap dumps. So I have mentioned here few ways. We have three ways we can capture heap dump. One is using Visual VM tool that can be captured manually. So in Visual VM tool, under Monitor tab, it provides us a button called heap dump. When we click on this heap dump button, it will capture us a heap dump for that particular point of time. So the heap dump will nothing but a binary file with the .hprof extension. The other way is to capture heap dump using a command line tool. So this JMap tool is available comes with the JDK. So this approach can be used in the scenario where the server machine runs short of the memory or short of the CPU. So in that case, we can go for this lightweight command line tool called JMap. So this is the command which can be used to create a heap dump manually for any particular time. The third way is to capture heap dump automatically when there is a out of memory occurs. So for this we need to add these two JVM arguments to our Java options, and it will capture heap dump automatically whenever the system runs out of the memory. So the first parameter mentions that enabling heap dump on out of memory, and the second parameter mentions about the location where this heap dump can be saved. So I would like to highlight one point here, like these two parameters are by default added to our AR server application. But for other applications like Midtier, Smart Reporting and Plugin Server, we need to add these explicitly, and for that we need a server restart as well. Again, the point to be noted here, like whenever we create or generate a heap dump, then at that point it may take few minutes. It may take few minutes to create a heap dump, and it may freeze the JVM also. So no user activity can be possible at that time. So just note this point. Next is a thread dump collection. So yes, so thread dumps can be used to debug the hang issues in application. And the best practice is to collect 10 thread dumps at a regular interval of maybe of 10 seconds. So we can collect thread dumps using in two ways. One is using our Visual VM tool. So for that you need to go to the threads tab, and under that tab there is a button called thread dump. Just click on it, and the system and the Visual VM will capture thread dump of that application for that particular time period, for that particular timestamp. So this is the one way we can capture thread dump. So once we capture thread dump using Visual VM, it will look like this, mentioned as can be seen in the screen. The second way is to capture thread dump using a command line tool called JStack. Again, this is a lightweight approach. We can capture thread dump using this, running this command from the command line. So here the command is mentions about the process ID of the application and the file name. So these are the two ways we can capture thread dumps. Now let us see how we capture application snapshot. So let's first understand what application snapshot is required for. So using application snapshot, we can find patterns of memory or CPU growth, or we can find we can predict if there is any leak. So to capture application snapshot in Visual VM, just go to the JMS connection for which we need to capture the application snapshot, and just right click on it, and there is one option, say application snapshot. Click on it and it will capture an application snapshot for a particular time frame. So the point to be mentioned here is this application snapshot by default can be captured for 60 minutes only, because that's the default configuration in Java Visual VM. And if you want, you can configure as per your requirement. For that, just go to Tools, Options, General, and there you will see this chart cache label. Under that there are two fields, monitored host and monitored data. So these two fields can be set to whatever time you want. Maybe you may want it to capture for maybe 12 hours or maybe for 1 day. So you need to put that time here and just say OK. Then the Visual VM will capture data for that particular time frame. Again, point to be noted for application snapshot is, if you are capturing an application snapshot on one JDK version and then sharing that application snapshot to someone else who is going to analyze that, and if that person is not using the same JDK version, same Visual VM instance of the from the same JDK version, then the data may be shown inconsistently. So you need to make sure that the person who is going to analyze this application snapshot should use JVisual VM instance from the JDK of same version. Now let us see how we collect garbage collection logs. So to collect garbage collection logs, we have these few standard parameters, or we can say standard JVM arguments, which we need to add in system properties. So these are the some parameters I have mentioned here. The first one mentions about the path where this log will be collected. Second one just enable the garbage collection detail logging. The third one just log the garbage collection activity with detailed timestamp. The fourth one talks about the garbage collection file rotation, and next one is the for number of files to be created for a garbage collection, and the last one says the size of each file. So these are few standard parameters I have mentioned here, which can be used over a production environment for collection of garbage collection logs. So this is how we collect the different kinds of logs using Visual VM tool and some other settings. Now let us see how one can analyze those logs or dumps using different tools. So we will be talking about heap dump analysis using Eclipse memory analyzer tool, then thread dump analysis using thread dump analyzer tool, and then analysis of garbage collection logs. So let's talk about each in detail. So yes, heap dump analysis can be done using Eclipse memory analyzer tool, which is a feature-rich Java heap analyzer tool that can be used to find potential leaks in any application. Also, this tool is capable of handling dumps with hundreds of millions of objects, and it can quickly calculate and return the sizes of objects. So this is how Eclipse MAT tool looks like. So I will show you one practical case where I will be creating one heap dump file and that will be analyzed using this Eclipse memory analyzer tool. So just sharing my screen again. So this is my Eclipse IDE where I have plugin for memory analyzer. If you can see here, the pointer shows that this is the plugin which I have installed in Eclipse IDE. Now this is one Java program, so sample Java program which I have created to create a heap dump. So what this simple Java program is doing, here I have created one array list, and in that array list I am adding string objects in an infinite loop, which eventually lead us to the out of memory error. And when I run this program, it will create as a heap dump for us. So I'm just running this. So yes, it has created one heap dump file for us. Now let us analyze that heap dump file using this Eclipse memory analyzer tool. I'm just going to file, open heap dump, and this is the heap dump file which is created with .hprof extension. I'm going to open it in MAT. Okay, so MAT has parsed that heap dump file and it is showing some statistic about the application. So you can see here, we can see histogram for that application, we can see dominator tree for that application. Also we can see some leak suspects report using this MAT tool. Now if you click on a histogram, it will show you in detail about the classes which are loaded in this application, and the number of objects created for each class, and the size which these objects retain. So you can see there is one object which has taken almost all the memory. Now again, if you click on dominator tree, it will show in detail about the particular object which has taken the size. So here in the main thread, if you can see, this object has taken almost 99% of the memory. And if you click on the leak suspect report, it will show you that the total memory allocated for this application was 79.4 MB, but out of which the problem area A has taken 79.2 MB memory. So this means that this is a problem suspect. Just if you scroll down below in this report, you will see in detail about the problem suspect. So it mentions here, like, my main method is keeping local variable of size almost 99% of the total size. And if you click on this track test, it will actually show you the line number from your Java application from where this leak is coming. Now I have clicked on that, and if you can see, it is showing me this line number in out of memory heap generator.java file, and it is line number 17. Let's verify it with our program. This is my Java program, and yes, this is the line number 17, which is responsible for the leak in the application. So this is how we analyze the heap dumps using Eclipse Memory Analyzer tool. Going back to the presentation. Okay, now let us see how do we analyze thread dumps using thread dump analyzer tool. So before that, I would like to give you some detail about the thread dumps, what data thread dump contains. So I have mentioned one sample excerpt of the thread dump. So here I am tried to highlight the different properties of a thread dump in different colors. So in the green, this mentions the name of the thread. Then in the purple, it's a thread type, and then in the orange, it's a priority. Then the thread ID and thread status. Then the other gray part is the thread call stack, and here you can see that this thread is waiting to get a lock on this object, on this particular object ID. And here in this line, you can see that this thread has already taken lock on this particular object. So this is how thread dump logs the data. If you go and analyze this thread dump manually, that can also be done, but there is a easy way of analyzing it using thread dump analyzer tool. So let me show you practically how that can be done. So this is a thread dump analyzer tool. Now I have one thread dump which I have taken from one of the customer issue, and there was a deadlock in that application, in the Midtier application. So I took that thread dump for the demonstration here. I will show you how that can be analyzed using this thread dump analyzer tool. Just open this thread dump file in this application. So this is the thread dump which we can analyze for the deadlock. So here you can see, if you click on this thread dump, it will show you detailed statistics about the threads for that application. It will show you count for the thread which are waiting for monitoring. It will show you the count for thread which are locking a monitor. It will show number of threads which are sleeping on a monitor. So in this way, this shows you a different statistics about the threads in that thread dump. Now I am interested to find out if there is any deadlock in the application. So for that, I just click on these threads. It's showing us that there are 373 threads. Now on the right side of this panel, it is showing details about each thread. So it is showing that thread name, thread ID, and its state. Now I'm just sorting this thread based on their states. And now I'm interested in the block thread, because mostly block thread might be into a deadlock situation. So let us take this thread which is named as http://bio-8080 exec-1690. So let's take this thread into consideration. So if you click on this thread, it will show detailed stack for that thread. Now I need to identify if this thread is into a deadlock situation. So before that, let me brief you about the deadlock. So deadlock is a condition where two or more thread can wait for getting a log which is already logged by other thread, and at the same time other thread would be waiting for the log to get which is taken by the current thread. So this way a deadlock can happen. Now I am taking some data from this thread stack to a text file just to identify if there is any log. So I am copying the thread name first. Okay, now for this thread I am interested in the object ID on which this thread is waiting. So this thread is waiting for this object. Let me copy that data. Okay. Also I am interested on all the object the thread has already taken a log. So this is the one object. If you scroll down, there are 3 more objects which already logged by this thread. Just copy that data. I'm just collecting the object IDs which are logged by this thread and the object for which this thread is waiting to get a log. So this is the data for this thread. Okay. Now you can see here this current thread is waiting to get log which is already taken or owned by other thread. So you can see the other thread's name here. Now I would be interested to collect data from this other thread which has already taken this log. So I'll find this thread name in this list. It ends with 1675. Okay, so this is the thread which I am interested about. So let us copy some data from this thread as well. Now this thread is waiting to get log on this object ID. If you can see here that this thread is waiting to get a log on this object which is already owned by thread 1690. Also interested to get detail about the object which already logged by this thread. Okay, so now we have data in a separate file. So if you can look at these 2 threads, the thread ending with 1690 has is waiting for to get a log ID which is already logged by the other thread ending with 1675. And if you see the thread 1675 which is waiting to get log on object which is already logged by the another thread. So this way these 2 threads are in a deadlock situation. So this is how we can analyze a deadlock condition from the thread dump, and that can be more easier using this thread dump analyzer tool, as you have seen how we do it. So moving back to the presentation again, and third one is analysis of garbage collection log. So for a garbage collection analysis, basically we look for 2 things. So for garbage collection activity analysis, we look for the 2 things. So one is we look for the frequency of garbage collection because in a healthy application, the garbage collection should be garbage collection cycle should be spaced out at some point. So if your application kicking garbage collection in fewer seconds, then you may have an issue, because garbage collection activity takes toll on the performance. And the other thing we will be looking in the logs, like the time which is taken by each garbage collection activity. So that should be within a few milliseconds or seconds. If it is taking a longer time, then again your application may have an issue. So the garbage collection log file can be analyzed manually as well, because it's a text file only, but that will be quite difficult. If you open the garbage collection log file, let me show you what the data logged into the garbage collection. This is one sample GC log file. You can analyze manually as well, but it will be quite difficult for you. The best way to analyze it, we have one tool that can be used. Before that, let me show you that sample garbage collection file. So yes, this is the sample garbage collection file, and this is the data which is logged into this file. So that can be analyzed manually, but it will be quite difficult. So now the best way is we can use an online tool for the garbage collection analysis. So this is a tool that is GCEZ. So here we can simply upload our GC log file and say analyze. So it will process the file and it will show you data in a graphical format, which is very easy to understand. So this application has analyzed my GC log file, and it is showing you the different statistics with the graphical charts. So you can see here the JVM heap size usage. So you can see the heap allocated for the young generation garbage collection, and peak used also for same thing for the old generation. Also you can see here the average garbage collection time taken for the GC activity, and the maximum garbage collection times, which is 200 milliseconds. So this graph is showing that the 91% of the garbage collection activity happened within 0 to 0.1 milliseconds, and some 8 to 8.7% of garbage collection activity happened between 0.1 to 0.2 seconds. Also it gives you the count of garbage collection activity happened between the particular time frame. So this way we can analyze garbage collection logs using this online tool. Moving back to the presentation. So I have given the reference for that online tool here in the slide deck. So this is how we do analysis for heap dump, thread dump, and garbage collection logs. So here I have mentioned a few references from which I have took some data points for this presentation. If you are interested, you want to dig further, you can use these references for your further studies. Okay, so I conclude the presentation here. Let us see if there are any open questions.
Great. Thank you, Chetan. I do have one question that I have. The question is the RMI administrator password encrypted?
Ashutosh, you would like to answer?
Yes, am I audible? Okay. Yes, that is correct. The RMI administration password, which actually we are talking about when connecting to the JMX port via JVisualVM or any other tool, it is encrypted, and it is also in case of AR server, that is Java server. The out-of-the-box built-in security that we provide is the AR server's administrator account. So the username and password is stored in user form. The password is encrypted, one-way encrypted, and it is stored in the database. So yes, short answer is yes, it is encrypted.
Great, thank you. There is a question I have from the Q&A about how can we identify the web service call performance issue to our panelists?
Yes, I can take that up. So web service call, I'm assuming that we are still talking about SOAP-based web services. That is our XML web services. So the call comes in via Midtier and goes to the AR server. So it could be, if you are seeing performance issues in web services, the problem could be either at Midtier side, or it could be at AR server side, or the network between these two. So the simplest way to approach this would be enable logs on both ends, as detailed logs as you can. Like in Midtier, you can enable all logs at the fine level, and on server you can enable API, SQL and filter logs. And looking at the logs, you will know whether it is API that is taking time, or whether it is Midtier which is taking time, or Midtier sent out the call but AR did not receive in time, or there is too much data being returned and network is playing a role here. Looking at the logs, you will know where exactly which process is where this is going to take is causing this slowness. And once you know what component that is, you can look at these tools that Chetan explained, and you can do more monitoring using any of these tools to that specific process. Hope that answers.
And then, like, this is Dinesh. Actually, I'm having a question, like, if the API call is taking more time, like how we can identify where is the problem lies?
Okay, I can take that up again. So I think, Dinesh, the first thing you should do is enable all logs, including API, SQL, filter, plugin logs, because there could be plugin calls which might go out, and that might be taking time. Using the logs, you can always do the basic analysis, where exactly it is taking time. It could turn out to be some SQL query which might be taking longer time, or sometimes we have also seen some customer issues where their communication between AR server and plugin server is not working out well. Maybe it's a problem because not enough threads are allocated, and which is why the calls are being queued. So you can find out this basic info from the logs itself. You don't need to specifically look at any of the JVisual or your kit for that matter. But once you know from the logs, if it is database or if it is communication between plugin server and AR server, you would know what the problem is. If that still doesn't solve, then you should definitely go for one of these tools for doing additional profiling. Use JVisual to take some thread dumps, to take some profiling, and analyze that to find out if where exactly the slowness is, where the time is being spent.
Okay, actually, like, I have found, I have an issue. What is happening is, like, the SQL is returning back the data at the perfect time, but after the SQL is returning, the API is taking too much time for building the data and wrapping and giving to the users. So what could be the reason for those things? Like, it's pure out-of-the-box code. Sometimes it's taking, sometimes it's working fine.
Okay, so if SQL is returning, then if you have also seen if there are any specific filters which are making additional calls to some external vendor plugins or something external, or maybe filters have some logic which is taking time in themselves, that one thing that you can find out still from the filter logs. Another possibility is if you do not have enough threads, it could still cause a problem. It is not able to respond in time. So if from the logs, if you are not able to find out, then certainly you should attach your JVisual VM with JMX. You can do some profiling. It will tell you exactly what happened after the SQL data was returned, and you will find where the time is being spent. And if it could turn out to be very technical, and if you can't make sense out of it, I suggest you open a case with BMC support, who will make sense out of your profiling snapshot.
Okay, thank you.
Hi, this is Jeffrey again. I have two questions. The first question I have is in the one of your documents. It states that the threading. It states that I think the min and the maximum should be set the same. Is that a hard, fast rule, or is it, like if we're having performance issues, should we have it set the same? Does it need to be set the same? Is that something that is absolutely required in order for everything to function properly?
So, hi Jeff, this is regarding the memory settings, right? The min and max settings that you're referring to. So you can have it as same. It will
No.
the start. Sorry.
Not Java, not Java min and max memory. I'm talking about threading in the AR server administration. I'm talking about threading, like the.
Okay, the list queue and the fast queue.
Yes, I'm talking about list queue,
Okay.
fast queue, those type of things. I saw in the documentation that that BMC recommends they be set the same. So I'm wondering if that is I'm just wondering if that's something that is an absolute requirement, or can you see performance issues if they're not set the same? Can you see performance or throttling issues or something if they're not set equal?
So, Jeff, they can be set not absolutely required that they should always be same. You can have a difference between the min and max. The difference would be when the server is idle and the load is less on the server, the number of threads would reduce back to the minimum.
Okay, interesting. Okay, thank you.
Yep. Yep.
Yeah, actually I have one question, like we have a configuration like for the maximum threads for list and fast queues, right? Is it related to the number of cores of CPU in the system, or like we can configure whatever we want for the threads?
Hi, so the number of threads, the size that you are going to set for the queue, it translates into the number of threads that get spawned into the server. And that should be supported by the underlying hardware system. So yes, it's related to the number of cores that you would have, and while tuning it, we need to take this into consideration, the hardware.
But actually, like in one of the environment, we have put more number of threads than the hardware. So, but it's still running without any issues. Like that's why I just want to confirm, like, is there any direct correlation between the system core and the threads?
Yes, so you can have the number of threads more than the core, but the size of the queue would translate into the number of threads that would be spawned. So at one point you would not be able to support it. The underlying hardware would not be able to support it. So the exact relationship between the threads and core is not available. We need to check about it.
Okay, like how we can identify, like is there any number of there is a lack of threads for the particular queue for the particular operation? Only through logs, or like can we find it somewhere else also?
Through logs, it would be the best place, because you would realize that all the requests which are going on that particular queue, they are getting responded slowly. So that is the best place where you can identify it.
In addition, there is you can also take thread dumps periodically, and if you are seeing that all your list threads are being consumed every now and then, that is an indication that there is possibly some traffic which is awaiting queues. So that might be another indication.
Hi, yes. I was just wondering, what are some of the most common issues that you see with Java in 8.1 and the 9X versions, and what are the first things that you look for in order to troubleshoot it?
Okay, so I'm assuming you are sorry, there was echo. I'm assuming you are talking about AR server here, which moved from C stack into the Java stack. Is that right, or you're talking about any other component?
Yes, I mean, anyway, like I support the AR system and our applications that are in the mid-tier. We have a lot of custom applications, and they're going to be run through the mid-tier. And, of course, they use the Java engine. But if we have any performance issues, like slowing, I notice it takes a while to load sometimes, some of the pages. What would be the advice you would give me to, what would be the first things that I would look at?
So the most important thing you should be via JVisual VM, you should look for the application snapshots, the way Chetan explained it. For every Java process, it will give you an indication whether it is consuming too much memory, whether it is taking too much CPU, whether we have slow increase in memory or processing that is going on. It will tell you about the patterns, how exactly your system is behaving. Is it going to run, it is going to predict for you kind of, whether it is going to run out of memory or is it doing too much garbage collection, and because you have not tuned the system well, maybe memory is not enough or threads are not enough. So you're connecting with JVisual VM and monitoring it, looking for things like memory, your heap size does not go, your memory basically does not go beyond something like 60-70% of your heap, which could be an indication. Your CPUs are staying below 60-70%. That is another indication. You see,
I'm sorry,
what is going wrong?
About the heap, about 60 or 70. What was that?
No. So I'm saying if you have allocated out of the box for Java server, it runs in 6 GB heap size. If you are seeing in a normal case, it will typically stay at around 3 to 4 GB when you have full user load. That will be the utilization. So I'm talking about roughly 60 to 70% utilization. If you are seeing it goes beyond that, it's going beyond 4 or 5 GB, it is probably not able to handle the load which is coming on that server. So that is an indication you should start looking for what's going on. Yeah. Similar thing for other applications.
Thank you. That's really good.
Okay.
Appreciate it.
Thank you for the question. And at this time, we are out of time for this session. We're past the bottom of the hour. Wanted to thank everybody for joining. We will be posting the webinar recording and the Q&A within a week of the live presentation. As contacting BMC via communities, social media, as well as the tech support lines for any problems or questions you may have. And as always, thank you for joining this month's Connect with Remedy webinar. Thank you.